Thank you. So one of the major mysteries of our universe is there life out there, or are we alone? Now, there are trillions of planets in the universe, so statistically it seems likely that there's probably some form of life, but we haven't actually been able to prove that. So next year, NASA's launching the James Webb Space Telescope, and one of the core functions or the core missions of the James Webb will be to actually go out to exoplanets and search for signatures of oxygen at the edge of their atmospheres. Now, oxygen is a good indicator of life. Not only is it required by complex organisms like ourselves, but it's also a byproduct of photosynthesis, a key mechanism in biology. So the problem with that, though, is that oxygen has only really been around for the last 14% of the 4 billion years that life has been on Earth. And so if we're going out into the universe and looking for life, we probably need to be looking for a lot of other indicators that signify the other time periods during Earth history where life existed but oxygen didn't. And so what geologists have done is they've broken up Earth history into different segments into what we call alternative Earths, time periods that had different biosignatures, different amount of diversities and abundances of life, and had different environmental conditions. So as part of my thesis, what I've been doing is I've been going out, collecting rocks, and trying to explore those early environments for their signatures. By understanding how these rocks formed and by evaluating their chemistry, what I can do is search for signatures that existed that are characteristic of these time periods and characteristic of the life that existed, and also understand some of the mechanisms that let us jump from one alternative Earth to another. So as part of my thesis recently, what I've been working on is understanding how the evolution of continents, of mountain chains, and the erosion of those actually drove the spur of evolution of life in the last 500 million years. And so the idea is that the erosion of the continents actually inputs most of the nutrients into the ocean. And so if we can understand that better, we can better understand some of the key requirements for the diverse biosphere that we've had the last 500 million years. Ultimately, the goal of my research is that if we can better understand the past, we can better understand what to look for out in the universe. So the next time that you sit around pondering sort of the origins of life and our position within the universe, remember that there's a geologist somewhere on a mountaintop, sweaty and covered in bug bites, looking for rocks to answer that very question. Thank you.